Hello, everybody, and welcome to KETIV Virtual Academy. I'm Tyler Hart, thrilled to host you for this week's training and thought leadership session. Today's topic is benefits of product configuration to engineering and beyond. Your expert today is Joshua McBride, a senior CPQ solution architect here at KETIV. If you have any questions during the session, please ask Joshua via the Q&A. Works better than the chat button. We'll either get those answered during the session or afterwards. And also, if you like what you see, all of these are recorded and available on ketiv.com or our YouTube channel. We also have a couple of upcoming events for you to be aware of. KVA topics include the difference between Autodesk Vault Basic and Professional. And then the next week, a session on designing space-ready electronics using ANSYS simulation. That'll be interesting. Also be aware that we're having an in-person event in San Jose, California on April 24th with ANSYS distinguished engineer Larry Williams. Larry is a super interesting guy, and if you're in the area, or even if you're not, please look into attending. Just go to ketiv.com, the homepage, and follow the links. So without further ado, I will pass things over to Joshua to kick us off. Thanks so much for being here.
All right. Well, thanks for the introduction. We'll just move right into it. We're going to talk about the benefits of product configuration to engineering and beyond. Of course, I got to get a little Buzz Lightyear kind of reference in there. All right. So quick introduction. Obviously, Joshua McBride. We're going to start by talking about what's called upstream thinking. And we're going to talk about some engineering issues that are typical that we see in all kinds of industries. We're talking about how automation can help with that, the power of AI, and then the effects on the business as a whole. So real quick, I'm a senior CPQ solution architect here at KETIV. I've previously got 20 years of engineering and automation, and a little bit about myself. And I mentioned this before. I love traveling with my family in our RV. And I also love astrophotography. So I'm hoping to put both of those together here pretty soon and catch the solar eclipse. And hopefully where I've scheduled to go, weather will work out because there's not a whole lot of opportunity for that. I think it's another like 40 years or something before a full solar eclipse will hit the US. So speaking of camping, we'll get right into our presentation. I'm going to start off with a little example here. So we'll kind of imagine it's a nice, beautiful day, and you and your friends or family, you're out camping next to a beautiful river, and you're enjoying the gorgeous scenery, and it's calm outside as the water flows over the rocks, and everything's real nice. But suddenly you see a child floating up the river and struggling to stay above the water. So of course you immediately jump in to save the child. And as you pull that child up to shore, your friend or your family, whoever's with you, they see another child floating up the river, struggling to stay afloat. They jump in as well and pull that child out. And bad as that child gets pulled out, there's another one. You jump back in, and it just continues and continues. More and more children continue to float up the river, and you can hardly pull enough out. You can't keep up, and you're getting tired. So you take a moment, you get on the phone, you call others to help. So more people show up, and they begin to pull these children out of the river, saving them. And but over time, they begin to get exhausted too. So more people jump in. You begin to acquire ropes to help pull these children, maybe flotation devices, in order to increase your efficiency. Soon you have medical teams that are established on site in order to handle the children that are being pulled out of the water, and the exhausted rescuers to help manage them. There's beds and tents are brought in order to continue to improve the efficiency and handle the ever-growing load. Eventually, you have engineers begin to design solutions in order to track the number and location of children so that rescuers can be better prepared as they come up this river. And maybe even they design a special structure, netting structure, and a bridge across in order to catch more children. And it just continues to increase. But eventually, somebody goes, hey, hold on. Why don't we just go upstream and see why these kids are falling in and maybe stop them from falling in, right? That seems like such an obvious solution when put in this framework. But the reality is we run into this situation so often in manufacturing and engineering and not realize what we're doing, that all these things we're adding on to try and increase efficiency, to reduce errors and these types of things are being added in some cases unnecessarily, when if we would just move upstream in the process, we could eliminate many of these issues. So let's look at a real world example here. Expedia. I think most people are familiar with Expedia, right? You can go there and book your travel. Well, their call center, they had high satisfaction rates. They had short call times. They had quick resolutions to those calls, which resulted in the call center employees being able to handle a large number of calls per employee. It doesn't really look like there's a problem, right? All these figures are very good. However, we think about it, they're not really that great. Somebody at Expedia finally noticed that, hey, 58% of all the calls were from people who just simply couldn't find their itinerary. So they changed the layout of the website, making it easier to find the itinerary. That resulted in a drastic reduction, 58% of calls no longer having to come in. And that resulted in an ultimate savings of $100 million. It's huge, huge, right? And all from moving upstream in that process as far as possible, right? So how does that kind of look in a manufacturing environment, right? We have all of these infeeds, right, that feed to the manufacturing floor. We ultimately start with the customers. We have that moves to sales and engineering. We have CAD and drawings. We have BOMs and the ERP procurement. Then we have all these things on the manufacturing floor that we try to make things more efficient. And I'm not saying these are bad things. They're great things. I've got certification in a number of these items. They are good and they're very needed. But there's also a lot of times where these things are being used in areas and in places that simply, if we move upstream, we can avoid. Okay. So we look at this as a whole, there's a whole lot of other pieces outside of the manufacturing floor that can be addressed. So let's look a little deeper, right? What are some of the key engineering issues that we see throughout the industry, right? We have the speed to market, right? We as engineers, and once again, I've 20 years as an engineer. I've lived this heavily, right? Speed to market, we've got extremely tight schedules. It's always needed yesterday type situation. Manual tasks, there's a lot of manual work that's being done, which results in inefficient processes. Sometimes there's a lack of awareness and the use of legacy systems that can result in slowing things down. It's very hard to balance the speed and quality, right? They needed it yesterday, but in order to really produce the quality and the objective needed, we're really out of time. Skilled labor shortage. We need more engineers in order to handle this higher workload, but getting ones that can understand the product, learn quickly, and learn the industry, all those types of things, that takes a lot of time, takes time away from me trying to keep up with my work as an engineer, trying to train a new person. I don't really have time for that, right? Then, of course, there's market demand fluctuations, particularly as of lately, that tends to fluctuate a lot. And of course, we have much more complex supply chains than we used to that are more vulnerable to disruptions, whether that's pandemic related delays and all the things that came along with that really highlighted those issues in the past. So how can we address these issues, right? So with a configurator and automation, we can do a number of things. Okay. So the key aspects here are we have a software tool that simplifies the sales process, right? If we're going to move as far upstream as possible via that previous chart, then we want to move as close to the customer as we can and address as much as we can there so that all our downstream processes are ultimately improved and impacted by that change. So we can do that by moving as close to the customer, by translating the customer needs into a technical solution, generating accurate quotes from that information, and then integrating it with the existing digital landscapes, such as CAD integration and automation from that information that we've gathered from the customers and run through a set of logic, right? We can also provide, for instance, what's called visualization, which is a immediate live feedback to the customer so that the customer can see what the results of their decisions are immediately. They can see the product that they will get immediately. And then, of course, we have the AI-driven product optimization. And what that is in which the customer can simply go, I want these things, but I want it as cheap as possible, or I want the most efficient version of this product, the highest performing version of this product, things like that. We can optimize with AI. And these are the types of questions that sales teams, sales engineers, and engineers that are supporting the sales teams often get and have to handle. It can be very time consuming. And so the load is ultimately moved away from the engineers to automation during the sales process. Okay. So let's dig a little further with this example. Okay. So oftentimes we have this flow of information, right? Which we have customer information, the customer talks with the sales team works back and forth with the customer. They then work with the engineer in order to figure out these specific aspects, and the engineer will ultimately design up the solution. They'll produce a set of drawings that moves to the shop, and then the shop ends up seeing a whole lot of rework. And of course, that is a big loss in efficiency, revenue, and so forth, right? So instead, if we can streamline these processes with automation, we can reduce that time in which that interaction with the customer occurs to the time we reach the shop, thereby increasing the output, but we can also increase the quality as well. And the other advantage here is we get a single source of data that flows through all of this instead of having it split out, copied, and multiplied, and duplicated. We can therefore trust that data and the quality of that data as well. And of course, this can once again be done with different solutions. In this case, Tacton, which is one of the key solutions we provide, is able to achieve these types of results. So let's talk a little bit about Tacton and what it can actually do, right? Because oftentimes we talk about automation, the immediate go-to is programming, right? Programming, it's heavy, laborious, and it's certainly not something engineers are prone to, right? And particularly because now we're putting another workload on the engineers as well when they're already loaded. Well, Tacton has a different approach than the typical. And this is through what we call constraints and AI. And that is used instead of what we would term general rules, right? The typical if-then type rules that are used in your general type programming. So not only are there limitations there, but then of course that programming language, now you have to learn a whole nother language, right? So we kind of have this example here to illustrate the power of the constraints in AI. So Sudoku, I think, that was very popular at one point. Most people are familiar with it, right? The general rules are that your rows have to, and columns have to have a unique number, and they have to in every row, which adds up to a certain amount, right? We can't reuse the number in any row or within a row or within a column. Okay. So in this example, we ultimately have 72 empty slots. There's 9 potential numbers that can go in each slot. So that means that we've got a 9 to the power of 72 possible solutions. Okay. Now that's just possible solutions. That doesn't mean that they're all right. Okay. So to code that with if-then statements for each individual slot is going to be incredibly massive, could result in thousands of lines of code. Then also, the more lines of code we get, the slower the configurator will run, right? With Tacton, we only need 10 rules or 10 constraints in order to make this produce a solution that is true and works. Okay. So with only 10 rules, that also means it can run a whole lot faster. This makes it a whole lot more approachable and manageable. And it also kind of puts things in terms that engineers are familiar with, right? The engineers are the ones that define the limits of the product, defines the relationships of the product. And this provides engineers a way to do that and provide automation through those definitions. Okay. So a real world example here in which Tacton was used with ABB. So they had over 200,000 coded rules, and that's just coded rules, not lines of code. So we're talking even more lines of code. Okay. These coded rules were all put into Tacton and condensed down massively. And in addition, this also provides additional functionalities that do not exist in standard coding, which gets back to what I mentioned earlier with the optimization, right? The configurator and the AI, in essence, understands all possible viable solutions. Therefore, you can say, okay, I want of all the possible viable solutions within my selection, I want the one that is the most cost effective. I want the one that is the most efficient, or maybe has the least carbon output, right? That's becoming a big thing with regulation coming up. The configurator can provide that solution. Whereas with engineers, we have to go discover each time what all those solutions are. And we may not understand all the possible solutions. So due to the sake of time, we have to come up with kind of our best guess. And of course, that also takes time. So with this, we can provide a no-code development platform, a platform that, once again, engineers can implement. And once again, engineers are the ones that are defining these limits anyways, right? So where they can define and capture this, and on top of that, provide automation. Additionally, Tacton provides a visual configuration for different design approaches, right? The customer makes decisions on highly complex products, and we can provide an immediate result. Okay. So, for instance, Mercedes-Benz, this is a quote here. They used Tacton visualization configuration for interior design, which supports their customers in the decision of their highly complex products. And so here we can kind of see an example in which we have not just a conveyor system, but a conveyor system with different automated pieces throughout. And the Tacton platform provides a way to define these complex systems and their interactions between each component and lay out these types of situations quickly and easily. And once again, provide the confidence, right, that we know this can be produced, that this is a viable solution. And therefore, we can move straight into providing a quote and reducing the amount of work and errors along the way. So let's look at kind of what do we get out of all this, right? Once again, going back to those issues that the typical engineer faces, right? So ultimately, this increases our speed to market. It increases productivity and ultimately our competitiveness in the market as a result, whether that's with existing products, getting from the point of interacting with the customer to producing a quote and producing the product, or bringing a new product to market, right? Building it into that automation, being sure that that we understand all the different possible configurations, what their prices are, and those types of things. That's all data we can get out of this system as well. And ultimately, rather than it taking days to weeks, or in some cases, we've even seen months, right? We can move that down to seconds or minutes from interacting with the customer to having a quote that is ready to be signed. Manual tasks and inefficient processes. By removing these manual tasks from the sales engineers, and our general engineers, this frees them up to do numerous things, whether that's now they can focus on using their deep product knowledge for creating custom designs, right? Because we always have that situation where, 90% of the time our standard stuff is good for the customer, and maybe 70% of the time. So we can handle that 70% with automation. And now our engineers that have, been working with us 5, 10, 15, 20 years that know things inside and out, rather than them spending that knowledge and time on laborious, repetitive tasks, they can now focus on that 30% that is special and custom that doesn't fall under the standard. Therefore, better utilizing their knowledge and better meeting the customer needs. They can also spend that time producing product improvements or expanding the product line, right? Once again, making us more competitive in the market and increasing our sales and revenue. This ultimately brings these systems tacked on, in particular in the AI and so forth, that brings the possibility, or brings us into being an industry leader in digital systems, right? Providing, once again, integration and automation into other systems, and so forth. So ultimately, we can balance speed, quality, and objectives, right? There's always that struggle. Now we can bring it into balance and get the highest speed while also achieving the highest amount of quality and making sure that we meet or exceed our customers' objectives and design expectations, right? So this ultimately feeds all downstream processes, right? We provide the shop with quality and quality documentation, quality configurations that we know are viable, that are low or completely eliminate errors, right? Then we have a whole lot less rework, thereby increasing the shop efficiency, right? All things along the way. Ultimately, these errors are reduced by having that same logic in the UI for direct sales, for partners and distributors, for end buyers directly to the customer, and engineers. They're all working from the same data set, the same rules and logic in that case. And then once again, we can meet the customer expectations and improve marketplace reputation. Once again, further increasing sales. So the Eldon Group, they in using Tacton, they say our process is much more rigorous today, and our orders are more accurate and error-free. Siemens, they went from 2 months in order to produce a quote down to 5 minutes in order to provide a accurate signable quote to the customer. Clearstream, they had a design time. Their engineers would spend 4 to 6 weeks in the design time to spending 1 day in the design time. And this goes back to, even if there is always a custom aspect to the product, not the whole product is custom, right? So we can configure that, 70, 80, 90% of the product. And so the engineer only has to deal with that 10 to 20% of the product each time. Focus on that. Um, CIO, uh, Vencomatic says, Tacton was the only solution we found that makes it possible to approach a configuration from different angles, regardless of the customer's starting point. This is one of the key aspects of that AI that Tacton uses. Rather than forcing the user to work through step by step, okay, they can start at any point in the configuration, change something, and see its effect to all other aspects of the options and configuration. So that is a big advantage there as well. GE Healthcare, they saw an increase in sales of 46% and an increase of sales in their standard product, or general sales was 46%, and their standard products an increase in 294%. And this is incredibly significant because our standard products are where we can be the most efficient and get the most money out of in that sense, right? Because we can set up standards in all aspects along the way, all the way down to manufacturing, which is where we get back to things like Lean, Six Sigma, and those types of things. Having standards provides an increase in quality and quicker and more efficient production, right? So the more of those standard products that can be sold, the more revenue we get as a result. So once again, kind of some other engineering improvements addressing the skilled labor shortage, right? It's always hard to bring on new employees. They have a big learning curve to overcome, and it takes away, the time of the engineers in order to train them and teach them. Well, with these types of tools in place, we increase the output of the current engineering staff and thereby freeing them up more. But then we can also quickly onboard new engineering staff, as their knowledge base does not have to be as deep because that knowledge base has now been moved into the automation logic instead of residing in people's heads or on paper somewhere to be discovered. Marketplace demand fluctuations. With this creates a more agile environment in which we can handle those fluctuations a lot better. Once again, by speeding up all these processes, that frees us up to handle those non-standard situations, such as changes in the product that we purchase, right? By having a better understanding of the rules, we can deal with those situations and change those configurations a lot quicker. And so if, we lose this product and we have to bring another replacement on, it's a lot easier to handle. And we have a lot more availability to handle those situations, right? And then once again, we can optimize our configurations for the customer's needs, whether that's price, lowest carbon footprint, highest performing, those types of things. And once again, the configurator is the one doing that. In order to deal with complex supply chains, right, we get immediate BOM data, ensuring early and accurate ordering and forecasting, right? I know at least where I've worked, in pretty much every place I worked, that's kind of always the issue. There's certain products, particularly with the pandemic and after, it's like we've got to know if the customer wants this or this as early as possible. And sometimes that would result in just defining something so something could be ordered only to get changed later, right? And then hoping, well, someday somebody else will order the same thing and then we'll use it at that point, right? With this, we get those early and accurate results, and that's the key. They're accurate. We know they're good information. So now we can start ordering quickly, getting things on their way. And of course, engineers can once again quickly redefine products for changes in the available parts and material. So, for instance, Caterpillar Propulsion, they said that they had complex drawings that were produced in as little as 20 minutes versus 24 to 60 hours, right? So here we're dealing with not just the customer side, but once again, that automation downstream of the customer, such as producing drawings. It's a massive time and reduction there. The Eldon Group said that Tacton ensures quality and accuracy because we know with certainty that the different components fit together and can be manufactured, right? That's often a lot of question. That's why we have such a heavy engineering staff, often making sure that what the customer asked for is possible, that this will work, right? Versus, once again, we can put that in the logic. The configurator will tell us, will this work? Is this possible? Even if you've never produced it before, we have the right logic in there. We can say with confidence, yeah, we've technically never built this configuration, but we know we can. ABB, once again, says that Tacton this totally integrated configurator allows design and productivity to go hand in hand, right? Normally these kind of feel to be in conflict, right? It's like it takes time to design. You're just going to have to wait. Productivity is going to have to go down, right? Doesn't have to be the case. So once again, kind of moving back to our illustration here of the general engineering manufacturing environment, right? So if we focus on these upstream areas, right, that's where we're going to have the biggest impact on these downstream areas, right? So just like with the river, if we focus solely in manufacturing, right, focus solely on the river itself, okay, there's only so much we can do, right? And we end up making, in some cases, things a lot more complex and adding a whole lot more things unnecessarily. Versus if we move upstream, look at our inputs, right? We've all heard the term garbage in, garbage out, right? We improve our inputs, then everything downstream gets improved, right? The one of the biggest catches here is quality control, which I've taken a company and made them ISO before and started a quality department in a company that had none and brought them to being ISO. And once again, very important. I'm not diminishing the importance of that as a core function, but it can also become very bloated when we rely on it to catch things that are coming from other areas upstream, right? So ultimately, this results in savings across the board. We have savings in the administration and of data and of data maintenance. We have savings from reduced order errors. We have time reduction savings, labor savings, and ultimately we get more profits from more orders. So I do want to take a moment and mention here, we do have a tool that will help kind of evaluate. Our sales team has a tool that will help evaluate each individual's company's situation and help kind of see what are the key areas that you will get improvement from implementing a configurator, particularly the Tacton configurator itself and its specific advantages. We can look at that and help evaluate that for you. That is one of the things that I also help do, although I work specifically on the implementation side. Sometimes I'm brought over to look at particular situations and determine, okay, how can we handle this, right? There's a lot of instances in which the general belief is well, this is too complex. This is too difficult. This is too unique. And that's generally not the case. And so that is sometimes where I'm brought in as the guy that actually does the work, right? To come in and go, yeah, let's look at this in detail. This is how we can handle that. And then we can look at, okay, what are those ultimate improvements that you're going to get as well. So with that, we will move into the Q&A. Looks like we don't see any questions as of yet.
Yes, we do not have any current questions. If
Okay.
anybody does have questions, please submit them to the Q&A now. Otherwise, obviously, You see the support at KETIV up on your screen. And if there are no questions, we'll give it another few seconds here. But Joshua, thank you so much for your time. That was fantastic. Anything else you want to say as far as reaching out for further help?
Um, well, yeah, just if you have any questions, email our support team or give us a call. We'll do our best to answer those questions as quickly as possible. And like I said, if who you get in contact doesn't have that answer, they will find it. If they have to come to me or to Tacton or whatever, we will work with you as best we can. We want to be your partner in that sense. And ultimately, our KETIV's goal is to improve American manufacturing. And so, I'm all about that, and I'm excited to run into new situations and see what we can do.
Fantastic. Thank you so much for your time today, Joshua. This will be on KETIV.com and the YouTube channel. And we look forward to seeing everybody next week. Thanks so much.
Thank you.